Join us as we delve into the realm of space robots, revealing groundbreaking technology and extraordinary missions shaping the future of space exploration. These robots are pivotal in exploring remote and challenging environments beyond Earth, facilitating precise scientific research, spacecraft maintenance, and laying the groundwork for future human missions. Their pioneering efforts redefine our understanding and exploration of the cosmos, pushing the limits of possibility. Space Perspective has successfully sold over 1,600 tickets for its spaceflights, generating approximately $200 million in revenue. Notably, in 2021, SpaceX Perspective initiated reservations for its Neptune spacecraft, designed to ascend to the stratosphere via a high-altitude balloon. The airtight capsule, accommodating 8 tourists and a pilot, will ascend to an altitude of 30 kilometers. Neptune will ascend smoothly at a speed of 19 kilometers per hour, with the entire flight lasting 6 hours. The size of the balloon lifting the spacecraft is comparable to that of a football stadium. Passengers in the capsule, for a price of $125,000 each, will enjoy the view of Earth against the backdrop of outer space's darkness, an experience akin to that of astronauts. According to SpaceX Perspective, commercial flights for Neptune are scheduled to commence by the end of 2024. The humanoid robot Valkyrie, also known as R5, is set to become the primary assistant for astronauts on the Moon and Mars. Designed to autonomously explore space and provide vital support to astronauts, Valkyrie is undergoing trials that will demonstrate its capability to remotely service autonomous and maritime power installations. NASA is conducting these tests in collaboration with Woodside Energy in Australia. Woodside Energy will evaluate Valkyrie's software and provide NASA with crucial data to advance the development of robotics for remote operations on Mars and the Moon, where astronauts may not be present. Valkyrie's duties will include inspecting and servicing infrastructure, as well as tending to plants cultivated in space. NASA aims for Valkyrie to handle repetitive tasks, freeing up human resources for more complex assignments. Additionally, NASA plans to leverage Valkyrie's experience at Woodside's facilities to enhance the design of robots capable of operating in challenging and hazardous conditions similar to those on the Moon and in future Artemis mission habitats. Standing at approximately 183 centimeters tall, Valkyrie has been under development for a decade. Equipped with 2 Intel Core i7 processors and a 1.8 kWh battery, Valkyrie can operate independently for about an hour. Its simplified hand structure features 3 fingers and a thumb, and its head has 3 degrees of freedom. The robot's design includes anthropomorphic features aimed at enhancing its relatability during long-duration solitary missions, aiming to make it more human-like rather than just a mechanical tool. NASA's Valkyrie humanoid, also known as R5, was created by the Johnson Space Center Engineering Directorate for the 2013 DARPA Robotics Challenge trials. Originally intended for disaster zones, Valkyrie saw a new phase in November 2014 when 2 versions of the robot were distributed to U.S. research labs for further development. Valkyrie is a humanoid robot with 44 degrees of freedom. It uses 25 series elastic actuators in the arms, legs, and torso, inspired by previous Robonaut designs. The remaining degrees of freedom include 9 rigid joints and 12 tendon-driven assemblies in the hands. Its modular design allows easy removal of each limb: arms, legs, pelvis, and torso. The arms feature a 3DOF shoulder joint complex with rotary series elastic actuators, along with elbow and wrist roll joints. The wrists have parallel linear actuators and single-axis load cells for precise hand movements in pitch and yaw. Valkyrie's hands have 4 under-actuated 3-link fingers, a 4DOF thumb and 3 3DOF fingers, with one finger having a passive adduction degree of freedom. Passive elastic elements help in opening the fingers, while the thumb roll is driven directly by a geared actuator. In 2011, Robonaut 2.0, the first humanoid robot in space without legs, was powered on upon arrival at the International Space Station. Equipped with 3 fingers and a thumb, Valkyrie is being enhanced to autonomously mine resources, construct habitats on Mars, conduct disaster relief operations, and collaborate with astronauts. In the quest to explore the cosmos, NASA has developed groundbreaking robotic technologies, and Robonaut is a prime example. This humanoid robot, with its dexterous hands and sophisticated AI, assists astronauts aboard the International Space Station. With capabilities to handle delicate tasks in space, Robonaut represents a crucial step forward in human-robot collaboration beyond Earth's boundaries. The exploration of other planets wouldn't be possible without the pioneering efforts of NASA's Mars rovers. From Sojourner to Curiosity and beyond, these robotic explorers have traversed the Martian surface, conducting experiments analyzing soil samples and capturing breathtaking images. The Surface Avatar project team has reported successful trials of remotely controlling robots from Earth's orbit. A series of robots operated in semi-autonomous mode within an artificial Martian landscape at the German Space Operations Center. NASA astronauts aboard the International Space Station monitored and adjusted their actions as necessary. The robot's objective was to conduct preparatory tasks ahead of astronauts' arrival on the Moon or Mars. Among the team was the humanoid robot Roland Justin, responsible for unloading the landing module and installing a seismic sensor. The mobile observation rover, Interact, and the scientific research manipulator robot, Llama, were also part of the operation. All actions performed by the robots were displayed on a controller screen with a first-person view. Astronauts observed the robots' actions and could switch them to avatar mode or fully autonomous mode as needed by pressing a button. Control was facilitated through an interactive joystick with feedback. The team successfully completed all experimental tasks within a 2-hour timeframe. NASA and General Motors have teamed up to develop an updated version of NASA's humanoid astronaut robot under the Robonaut project. The primary objective of this collaboration is to advance technologies for space exploration, specifically aimed at assisting astronauts and improving their safety. Robonaut 2 features a humanoid design with a torso, 2 highly dexterous arms, and a head equipped with a vision system. This robot is capable of writing, grasping, stacking objects, and handling heavy items. Each of its hands is equipped with 5 fingers, each jointed similarly to a human hand. Robonaut 2 can lift weights up to 9 kilograms, extending them away from its body while maintaining balance. It represents a significant advancement in both dexterity and strength for humanoid robots, designed to work alongside humans in space environments safely. Robonaut 2's tasks include replacing humans during spacewalks and conducting repair work within pressurized compartments. While theoretically capable of mimicking human movements, practical challenges remain in fully achieving this capability. Kurobo, Japan's pioneering robot astronaut, was developed by the University of Tokyo and Tomoda Takahashi to accompany Koichi Wakata, the first Japanese commander of the International Space Station. Kurobo embarked on its journey to the ISS aboard JAXA's H-2 transfer vehicle Kunitori 4, launched from Japan's Tanegashima Space Center on August 4, 2013, and arrived on August 10, 2013. A twin of Kurobo, named Mirata, was created with identical characteristics as a backup crew member stationed on Earth. The name Kurobo is a blend of Kibo, the Japanese word for hope, and Robo, a common shorthand for robot, symbolizing its role as a harbinger of hope in space exploration. Jitai, a Tokyo-based company established in 2016 by Sho Nakanos, focuses on developing robots designed for operations in space and on lunar surfaces. In 2021, Jitai successfully conducted its inaugural demonstration aboard the ISS, with another plan for outside the station in 2024. The company has already secured $47 million in investments from major funds dedicated to robot development and has ongoing collaborations with Toyota and the Japan Aerospace Exploration Agency, or simply JAXA. Looking forward, Nakanos envisions deploying thousands of robots for missions on the Moon and Mars, aiming to enhance the accessibility and practicality of space exploration by mitigating risks to human astronauts. According to Nakanos, utilizing robots instead of humans could potentially reduce operational costs by a factor of 100. Jitai is currently developing a 2-meter robot inspired by a caterpillar, designed to move similarly to the insect and capable of being outfitted with attachments such as drills or shovels for a variety of tasks. Nakanos believes these robots could significantly decrease the necessity for astronauts to conduct spacewalks, particularly for repair and maintenance operations on spacecraft and space stations. A European consortium, including the German Research Center for Artificial Intelligence, has developed technologies under the PROACT project, enabling multiple robots to collaborate in constructing facilities and executing intricate tasks in preparation for space missions. One of the robots involved is Mantis, a six-legged robot designed for mobile manipulation research across various disciplines. Mantis operates in two distinct postures to accommodate a range of tasks. In its manipulation posture, the robot uses its four rear legs for movement and its two front legs for manipulation tasks. Alternatively, in its locomotion posture, Mantis walks using all six legs, providing significant advantages in challenging terrains. This dual-mode capability allows the robot to handle complex scenarios with a single system, facilitating the evaluation of various software components and planning methods within diverse operational contexts. Chinese researchers are advancing humanoid robots designed to assist astronauts aboard the Chinese space station. These robots, collectively known as Chinese stars, include a free-flying humanoid weighing 25 kg and standing over 5 feet tall. They are categorized into three types: a humanoid robot for daily astronaut support, a ground-following robot for filming and object carrying, and an on-orbit service robot capable of crawling and performing simple spacecraft maintenance. Future applications could include risky tasks such as solar panel cleaning or equipment inspection, allowing astronauts to focus on exploration. In addition to humans, the crew of the International Space Station includes NASA's flying robotic assistants known as Astro-B robots, floating alongside astronauts in this space laboratory 400 kilometers above Earth. Honey, Queen, and Bumble were delivered to the ISS at different times starting in 2018, with Honey and Bumble being the first to arrive, followed by Queen. These robots deviate significantly from traditional humanoid designs, each being a 30 centimeters wide cube distinguished by their individual colors. They play a crucial role in assisting the ISS crew with tasks that are important yet tedious, such as inventory management, documenting experiments using built-in cameras, and transporting cargo throughout the station. By 2023, NASA reported that the Astro-B robots had accumulated over 750 operational hours on the ISS, successfully completing more than 100 tasks, and showcasing capabilities that were once confined to the realm of science fiction. These capabilities include autonomously reporting and investigating simulated anomalies aboard the station. In August 2019, a Soyuz rocket departed from the Baikonur spaceport in Kazakhstan carrying an unconventional traveler, Fodor, Russia's inaugural life-size humanoid robot. The mission's objective was to test a new emergency rescue system, assessing whether an unmanned rocket carrying a robot could assist astronauts in distress. Fodor also spent 10 days aboard the International Space Station, where it learned skills such as connecting cables, using tools like screwdrivers and fire extinguishers in a low-gravity environment. Standing at 1.8 meters tall and weighing 160 kilograms, Fodor has its own social media presence on Twitter and Instagram, updating enthusiasts on its progress. Russia aims for humanoid robots like Fodor to eventually undertake perilous tasks such as spacewalks and operations in high-radiation environments. In late March 2021, Android Technics entered into a contract with the Russian space agency Roscosmos to develop an advanced robotics system tailored for spacewalks. Named Andronavt, this humanoid robot is a joint effort between Roscosmos and Robotics. The initial phase aims to finalize the prototype's scientific equipment by late February 2022, followed by ongoing work on the robot's composition, components, and protocols for docking with the International Space Station. Introducing Spacehopper, a creation by engineers from ETH Zurich's lab. This compact, three-legged robot is specifically engineered for operations in low-gravity environments, such as on asteroids. Utilizing neural networks for learning, Spacehopper has mastered the skill of jumping and maneuvering across surfaces, leveraging the minimal gravity of celestial bodies to navigate and stabilize itself mid-air before landing safely. This capability allows Spacehopper to traverse significant distances by repeating its jumping process effectively. However, validating its functionality under real conditions is crucial. Sending Spacehopper directly to the nearest asteroid isn't the most efficient or straightforward way to verify its capabilities. To address this, the robot underwent testing in a microgravity environment through collaboration with the European Space Agency and Nova Space, a company specializing in zero-gravity flights. During these tests, Spacehopper successfully demonstrated its operational prowess in conditions with even lower gravity than that found on an asteroid. The creators of Spacehopper envisioned that deploying this robot on an asteroid in the future could offer astronomers new insights into the universe's history and deepen our understanding of the solar system's earliest epochs. The humanoid robot RH5 Manus, developed at the Robotics Innovation Center of the German Research Center for Artificial Intelligence under the Transfit project, serves as an assistance robot for environments like future moon stations. It was designed to autonomously perform complex assembly tasks, collaborating with astronauts and operating under teleoperation. Key modifications include a revised upper body, arms, and sensor-laden head to enhance visual and acoustic perception. The robot can be teleoperated using an exoskeleton, utilizing virtual reality to transmit its sensory data and physical interactions. Initially deployed on a passive platform, RH5 features an interface compatible with its leg system. RH5 Manus employs a hybrid serial and parallel design to optimize weight and stiffness, enhancing its dynamic capabilities. The arm drive components were refined, with mass redistributed to shoulder joints for improved performance. Modular grippers, available in 2-, 3-, and 4-finger configurations, include adaptive features and a haptic sensor system, facilitating easy replacement on the robot. In October 2023, Jitendra Singh, the Union Minister of State for Space, announced the start of trials for the Gaganyaan missions by ISRO. He also revealed plans to launch a Vaya Mitra, a female spacefaring humanoid robot, as part of the mission's second phase. Vaya Mitra, meaning space and friend in Sanskrit, debuted in 2021 during an event on human spaceflight. It can monitor module parameters, issue alerts, operate switch panels, interact with astronauts, and simulate human functions in space. Meet RoboSimian, a spider-like robot jointly developed by NASA and DARPA. Designed to operate in challenging environments, RoboSimian features 4 limbs with multiple joints and was created as part of DARPA's Robotics Challenge. This versatile robot excels in navigating diverse obstacles and has demonstrated the ability to open doors, clear debris, climb stairs, and handle construction tools. These capabilities are especially valuable in disaster relief scenarios where human involvement could be perilous. RoboSimian is equipped with 4 robotic arms, each segmented to facilitate agile movement. Its unique body shape and design also enable efficient stair climbing. While capable of some autonomous movements, RoboSimian is primarily intended for remote operation. Looking ahead, this robot is envisioned for potential use in military applications by the U.S. Army and has applications within NASA's space programs.